right, glad we can get going. I will talk about a little bit about Industry 4.0, what Desoutter is doing in this new connected environment, and then some implications of that. But I'm really glad, since we're talking about a connected environment, that we could actually connect the computer so that you can see the presentation. So these are some of the challenges we face in today's world. But I'm just real curious starting out. Obviously, we're in an environment with much change, and one of those that'll be coming soon is driverless cars. I'm just curious of those out here. If you left today and you jumped in a vehicle, are you comfortable getting in a driverless car? Anybody out there? Okay, some. So you're willing to get in a driverless car. What might you want to worry about? You may want to worry about driverless trucks, because driverless trucks are coming as well, and they're going to travel in convoys on our highways across the country. So are you still comfortable getting in your driverless car with driverless trucks out there? And then the next step from that, obviously, if we want to go, from a city in California to another, we may take a pilotless plane. So these are all actual concepts being worked on that we will see in the very near future. This is one from Airbus, literally to be an air taxi, around some congested parts of the country. So, and just curious, pilotless plane, are you good with that? Some yes, some no. So, but whether it's cars, trucks, planes, they still all will need to be manufactured. And the way that is happening is changing, and it's changing quickly. So we live in a changing environment. We're in a very different connected society than we were even 5 years ago, and that change will happen very quickly now. So we'll talk a little bit. There's many talks about Industry 4.0, so I'll try to move through this fairly quickly, but it's all relative to the Internet of Things, this connected world where our coffee maker, our assembly tool, our phone, our vehicle, all are interconnected, all can exchange data and information in a rapidly changing world. Just in some numbers, by 2020 it's projected we will have 4 billion connected people. And even as you're sitting there, you're probably going to stay connected in some way to somebody else who's outside this convention hall. This represents a $4 trillion economic opportunity. And by 2020, the projection is there will be 25 million different apps that would be available to consumers to use. And by 2020, 50 billion embedded smart devices. So again, a rapidly changing landscape. And it all is reflective of what we call Industry 4.0. And that follows, of course, the first three industries. Industry 1.0 being the introduction of steam engines into the workplace. That was followed by, about 100 years later, the introduction of the assembly line. We often think of this with Henry Ford, but really started in the meatpacking industry in the 1870s. And then that was followed about 100 years later with the introduction of the microprocessor. And now we're moving to a more computerized world and PLCs and things that can control our functions. But those are really the first three, and we've operated very much in this Industry 3.0 world for a long period of time now. The change is coming, and it's here, and it's upon us. And really the shift is from what was an Industry 3.0 world and a way of thinking was really rather linear. We had our tools, we had our PLCs controlling them, we were maybe collecting data on top of that in a very linear structure. And the Industry 4.0 world is very much more like a sphere of interconnectivity. We have multiple devices talking to multiple other devices or machines and people interacting through this web of communication. And it's important to think of this change so that it's not just a linear structure anymore, but it's really more like a three-dimensional sphere. So some of the benefits of that would be, for us, flexibility, much more able to customize products and things as we build them, new business models, really changes the competitive landscape compared to the people that adopt to an Industry 4.0 mentality and those that do not. And then increasing productivity and the ability to adapt your workplace. So we've really, up to this point, worked in a way where we had the human interacting with their workplace, and we've been very much reactive. We very much looked at the past, looked at what happened as far as statistics, processes, things like this. And if we had an error or situation, we would put a process in place to stop that from happening again. But that very process may involve a lot of inefficiency that's not necessary. And in the Industry 4.0 world, we become much more proactive. And not only ourselves, but our machines, our devices, through the data that they generate, can create a much more proactive environment for our manufacturing facilities. And when I mention data, you'll hear this term often, in the news, internet, here, places like this, but big data. What does big data mean, and what is its growth in the environment today? Well, in 2012, this would be the amount of big data just being generated and being transferred in this Internet of Things environment. So this is measured in exabytes, and I looked it up, and exabyte is basically a really long number. It's really big. So by 2016, that about triples. So significant growth, and by 2020, that number will grow by 4 to 5 times. So the growth is exponential. And what's really important for our organizations to understand is that if we don't have systems and processes in place now, if we're still using Excel spreadsheets to control our business and we're passing papers around in folders and things, you're not falling behind at a linear rate, it's actually exponential. So for every year you remain stagnant, you actually fall 3 years behind. So the difference will become very evident here at 3, 5, 10 years down the road as to who adapted and who did not. These are some pull quotes from a white paper from UPS on the topic, and just talking in general about the landscape, the gap is widening between the companies that are aggressively embracing smart operation principles and those that are falling further behind. Furthermore, the seamless connectivity and automation now possible is what industrial manufacturers simultaneously find both enticing and intimidating. Kind of like the pilot of this plane, driverless car, it's like, hey, that's really cool, but I'm not sure what to do with that. And then lastly, whether you're a small or large company, because this is not something just for the very large enterprises, this is very much for the medium and small enterprises. Leveraging the data you already have into meaningful insights puts you that much further ahead of the game. And this is across not just manufacturing, but obviously transportation, retail, every industry is affected by these changes. So what are some coming attractions from our company, from Desoutter? How do we address this change in the environment? So what I'll talk about now are a couple of new tools, but basically this piece is still mechanical. And while we talk about Industry 4.0 and the advancement to it, the rest does not go away. Those foundations of mechanical innovation and complexity are very important in this future growth. In a way, they become more important as we are more reliant on our tools and machines. They have to perform in the best way possible to meet the requirements of an Industry 4.0 world. So we talk about buzzwords that we've talked about for years at this show. We talk about torque accuracy, repeatability, rundown strategies, ergonomics, power to weight ratio on hand tools, cycle time. Can we reduce cycle times in our manufacturing environment? None of those things go away in the Industry 4.0 world. In fact, they become possibly more important. So the first thing I wanted to talk about, which is really cool, is this tool from us, which is a cordless pulse tool. Desoutter launched years ago the ePulse, which was a cable tool. Great thing about it, it replaced the air pulse tool and some of the service issues that went along with that. So now the operator has an extremely ergonomic tool. With this tool, I could run a bolt down to 25 Newton meters with absolutely no reaction on my hand, wrist, or arm. This is very important to reducing repetitive stress injuries, which can be very expensive, obviously in a production environment. But now from Desoutter, this is available not as just a corded tool, but as a battery tool. So the operator literally can operate without any tether to a controller, whatever it might be, and they have multiple parameter sets on this tool. They can perform multiple functions inside an aircraft, inside a vehicle with this same tool. So next up would be this tool, again along the lines of ergonomics, just basically a compact nut runner. So now something very simple, up to 17 Newton meters, an operator can hold this in their hand, and when an operator can hold the tool in one hand and use the other hand, they become about 30% more productive. So Very nice to take an angle nut runner and reduce this size, but still provide the ergonomic benefit of that. So this one's kind of cool. In my current role now, I manage our aerospace team within North America. So I spend my time at Boeing and Lockheed and Northrop Grumman and places like that. So what do we think of when we see it? A Swiss Army knife does a lot of things. So this tool will be the XPB. We'll launch it next year, and this is a cordless drill. So you see that? Okay, that's nice, a cordless drill. So runs at a high RPM, and that's great. But there'll be 4 versions of this tool. And the next version will offer different parameter sets. So just like our torque assembly tool, we have different parameter sets, we have different parameter sets on this drill. So now the operator literally can work on one application here, change their parameter set in their RPM, and drill a different material here. So nice innovation, but the next step for that is actually to add multiple outputs. And through a special, head, you can snap on different outputs, so now you do not have a drill. We actually struggled with what to call this tool because it's not just a drill, it's something more. But now you have a tool that with one platform you can do temporary fastening, you could do advanced drilling with hydraulic control, and this will even have a head that will help the operator make sure that they actually provide the correct thrust throughout the drilling operation. Again, all interchangeable. And then the next piece of this would be RFID communication. With the heads individually tagged, now the tool knows what is attached to it and what process it's supposed to perform. And when I talk about aircraft, I spend a lot of time working with these folks, Boeing. And this actually is the 737 made in Renton, Washington. Renton is the highest producing aircraft factory in the world. They produce about 46 737s a month, and they're working to increase that production to roughly 52 here within the coming months. So big opportunities for improvements in efficiency. I actually stood, and I pulled these pictures from the internet, but I actually stood at this very cell last Friday. This is the Spar assembly for the wing of the 737. So we're used to seeing manufacturing as, we stand at a station and the part comes to us. In this particular factory, you have a very large part, and your station might just be these 2 or 3 feet. The part stays there for about 5 hours, and the people work at their different stations doing all kinds of drilling, fastening, assembling components. To the left is our CityTech drill. This is a pneumatic drill. He's drilling through aluminum into titanium. This is the engine mount on the wing. They consider this a critical application for some reason. But this is what holds the nacelle onto the wing that holds the engine when you're flying. So very important. With the pneumatic drill, which is extremely efficient, it takes him about 8 minutes to drill a hole, and he has 14 holes to drill. So just under a 2-hour process. What we've done at Desoutter and CityTech is advance that, just like DC tools, to an electronic drilling unit, referred to as the EDU. Now, just like a DC tool, there's an interface. You can dial in your RPMs and feed rates. Thus, you can drill aluminum and titanium much faster and more efficiently than you could previously. This takes the cycle time in that station from just under 2 hours to now something under 20 minutes. The drilling time moves to about 1 minute and 15 seconds with that tool because you can adapt to the materials. So, very important innovation, but I would say all of those are mechanical. All of those are Industry 3.0 types of innovations that we've seen come over the years, which are great, which are needed, but we're obviously moving to the smart factory type of environment. So what Desoutter is doing and what we look at, there's really a change of mindset, where to this point we've had tools, and what will happen as we move forward is we have smart tool platforms. The tool really is not just a singular function tool, but a platform to perform multiple functions. So everything I just talked about and more things, what's cool about them is they can all be connected. As we talk about this Internet of Things, they can all be connected into this new production environment. So they all become a platform. To help facilitate that connection, Desoutter will launch next year a new controller, which really being referred to as an industrial hub, the Connect. And the Connect is a new way of controlling tools. So you'll have a an inventory or on your line a number of battery tools that can operate, and through the use of the Connect, you now have something. If you've ever bought a car and you wanted one particular feature, but you had to get the highest level model to get that feature, you won't have to do that with the Connect, because it will be feature based, and you'll have a much more flexibility as to what you put on the controller and what you don't need for your particular application. And then within the production environment, you can move those features around from controller to controller as needed, and you can rebalance your tools and move them around the production line facility. So again, a much more flexible concept in the new production environment as far as controllers are concerned. So we've got tools, we've got controllers, but we need to control processes as well in this new Internet of Things world. So Desoutter offers a process control platform, which is Pivotware. And with Pivotware now, we can control all of these tools that I've talked about, but anybody else's tool or anything that has a sensor or intelligence, we can now control that and add that into our process. So what's cool about Pivotware, and what's really nice where we are in this stage of development, is that it is scalable. It doesn't have to be an enterprise-wide initiative. Pivotware can be added, from the single station onward, and then you can build up. But you can keep trend with this trend of what's happening in the Industry 4.0 environment. So a very scalable environment. It could be a simple assembly station. It could be an entire line. It could be the facility, or it could be multiple facilities. But it's scalable and something that can be layered on as needed, as the company deems the investments worthy to move into the smart technology. So that's all great. We talked about processes, tools. We have this advancing platform, but what you'll see here, and what also is new from Desoutter, and you see a lot of it at the show now, is automation. Automation typically has been thought of in the Industry 3.0 world as, large cages, robots that are, protected from people and people protected from them with lockout tags and things like this, and automation is becoming much more small scale. So what we're working on, as you saw the drilling application earlier, is marrying cobots, small robots that can work with people, with our SETI-Tech line of drilling tools. And these tools will be able to not only fasten, but they could possibly apply sealant, do riveting, and some of those functions. Some of those functions that are very difficult when I showed the Spar assembly line. Riveting is a very unergonomic type of process that is still very prevalent in the aircraft industry and others as well. So big opportunities to reduce injury, integrate process control, and more. And this is not just true for us in aerospace. So the same things are held true for some things we're working on in relation to automotive assembly. So here again, I showed where you could picture in Boeing, maybe the gentleman's doing his drilling, and next to him would be a cobot doing riveting or something else. Obviously, in the automotive assembly plant, you may have cobots on the line as well, performing functions that might be difficult for people, or we can rebalance the workforce to a more efficient layout. So, again, all things that Desoutter is working on now. So we have this whole environment of smart tools, Industry 4.0, and the movement forward. I wanted to talk a little bit about the environment in general, the Industry 4.0 environment, because the key to it, as we mentioned before, is data. And what do we do? What if you come to this show and you're, wow, everybody's doing Industry 4.0. What can I do at my facility? I'm a small-sized plant. I'm a medium-sized plant. And the first thing they say when you read on the topic is really, just develop a plan. Start now. Develop a plan for what is coming and what is changing. And one step of that plan is simply to get your devices talking. And this can be the tools that you have, this can be other things with the addition of sensors, but try to start to get your plant and your devices talking. Collect the data. And when we collect the data, use that and analyze it. And the thing when we talk about data, that there will be all of this data collection in the future, actually you probably would find you have a lot already. It may not be in use, but you already are collecting quite a bit of data. And get that data quickly to the people that can use it and make better decisions. But key to this also, as I show these products and products you'll see here at the show, when you make decisions now about your factory, don't always rely on what was tried and true, but really consider connectivity. How will this investment in tool, line, whatever, how will this connect into my future environment? Where do we want to be? Make that a culture of change within the organization. And I find when we talk about the organization, it's very important that that message of continuous improvement is prevalent throughout the organization. And this can be very foundational to some organizations. They might, we've always done things this way, it's always worked, so there's really no need to change. And you won't see any real change in your business in the next few years to come. But down the road, that could be significant if actions aren't taken now. And as I said before, if the systems aren't up to date or very antiquated, the change is happening exponentially. So it will occur quickly, and one can quickly fall behind. We find, as I've talked about tooling and process control and automation, when we go into a facility, oftentimes these are completely separate organizations. We'll talk to the assembly people, this is great, but the automation people are a completely different group of people. And all of this involves the interaction of the IT teams, which sometimes are only involved in things after they've been purchased. Okay, how are we going to connect this thing that we just bought? So the systems, the automation, the assembly need that matrix organization. So there's that sharing of information, sharing of decisions and processes as we move forward. And then it's very important to secure the assembly line. Obviously, we would secure a physical asset. We would go into our facility and secure the tool, the computer, the desk, whatever it might be, the coffee maker, they all get an inventory tag, and we're used to securing those things. But we have to secure data as well. Data is an intellectual asset. Your company invested time, money, and energy to create that, just like they did the products that they produced. So very important that it's treated as such. And so some of those treatments would include ensure that it's being used correctly and ensure that its access is controlled. So furthermore on data, very basic thing, obviously we want to back it up. This does not always happen, so it's something to take into consideration. How will it be stored? Will this be stored within our enterprise? Will this be stored using cloud-based systems, this type of thing? These types of decisions need to be made, and these types of systems are available in today's world. How will we define it? We obviously don't, as we build data, it becomes a data-based society. We need to disseminate who gets what. The management team obviously needs a different set than the production team or the process data, so we need to see obviously which set for the correct people. And then very important that we protect it. Again, the data is an asset that needs to be protected. And I found in this business when we're selling tools and controllers, one thing we always run into is just the curious. We always have curious people that, what happens if I push this button? What if I change this program? What if I change this cycle? And oftentimes the curious, while maybe well-intended, bad results happen as a result. So we need to protect from them, but more importantly would be the malicious. And you, every day, can read in the news stories about a system being hacked, somebody's company being taken control over for ransom, these types of things. So in checking this out, I looked at, this is actually from Deloitte University Press, and again, very basic, but every industrial innovation has had risk. And we face risk now, which needs to be addressed. The risk in Industry 1.0 was that steam engines could blow up. Big risk to these brand new devices coming into the workplace. Industry 2.0, the introduction of the mass production line, again, great innovation, but the early production lines were very difficult places to work for workers, working at great risk. The repetitive stress injuries alone were very significant in an Industry 2.0 world. So as we moved into Industry 3.0 and Industry 4.0, the cyber risk becomes much more prevalent. And so the key thing here is to develop your plan according, just as you develop an Industry 4.0 plan, develop your cyber risk assessment. And I like this whole quote, organizations should utilize good hygiene techniques such as network segmentation and intermediary systems that serve as middlemen to gather, protect, and provide information. But what I liked about that was the good hygiene, that we develop very good practices from the outset for what is our intellectual asset, just as we would for the protection of the physical assets. So And a little more on that, and there's reams of information one could read on this, but in this particular case, they're looking really at it as three separate functions. The digital supply network, your organization is in communication with outside suppliers, customers, things like this. Is that network protected correctly? You have the smart factory itself and its processes, and then you have the actual connected object and the protection of it. And they really looked at it at three levels. A, we need to secure it. Then we need to be vigilant in that security, be aware of oncoming threats. And then lastly, be resilient, be flexible to change. We can't put security systems in place such that it limits what we're trying to achieve in the connected world. There is an obvious balance there, but the key is to think of these things simultaneously as one advances into the smart assembly world. So to kind of sum this all up, if we can sum this up, in one simple slide, very important now that you have a culture of continuous improvement. And in addition to that, what you can do right now, think about this at the show, get the devices talking. We have processes going on in our plant where we're not collecting any data or any information. And then we take that data, we collect it, and we use it. Also very important that I stressed earlier, make decisions now that facilitate the future. What will your plant look like in 5 years, 10 years? Are we making those decisions now of things we can scale in, such as a pivotware, smart tools, that will be able to be connected to these future innovations? And then, as I said, develop a parallel plan for your cyber risk. Be ready for that, and even though you might be a small manufacturer, medium-sized manufacturer, take that into account as you develop this. So here at Desoutter, basically, we are working on a world of intelligent tools. Assembly tools, drilling tools, tools that will be used in manufacturing that have that future consideration, all of them being able to produce data that's the key of the Industry 4.0 world. And with that, it gives the ability to boost uptime, boost flexibility to the plant floor, and ultimately boost productivity.